With this one, we're working with rational expressions. We're going to be subtracting this one. Typically, the very first thing that you want to do here is identify what the lowest common denominator is. Well, on this one, the lowest common denominator happens to be 4m squared n, which is what we have on both of these. So because they share the same denominator already, that makes our life really easy. We don't have to find common denominators, they're already there. With the denominators being the same, the bottoms being the same, we simply just add what's on top. So let's do that now. Okay, and you'll notice here my use of parentheses. Parentheses are important on this one because this negative here will apply to the 5 as well as the 2n. This is not just 3m plus 8n minus 5n minus 2n. That would be incorrect because this subtraction sign here applies to both of these two. So that's why I use parentheses here. I find that if I use those parentheses, I'm less likely to make an error. All right, so now let's distribute that negative sign out in front. That makes this negative 5m plus 2n because we have a negative minus 2n. So that gives me a positive 2n. Now I look here and I say, okay, I've got some m's here that I can combine. Those two will definitely go together, and my n's go together as well. So now I'm left with negative 2m plus 10n all over 4m squared n. All right, now this looks like we're pretty much done here. The problem with this is it's not completely reduced. Okay, I've got 2, 10, and 4. So I look at those and I say, okay, I can take a 2 out of each of those parts. I can reduce it all by 2. So I'll do that. I'll divide each part of those by 2. That will give me a negative, there we go, each one of them by 2. I get a negative m plus 5n all over 2m squared n. This is my final answer. I cannot reduce these m's because of this addition sign here. Now up here, I could factor out a 2, which is essentially what I did. I factored out a 2 here. Then I could reduce it by this 4. Most students like to just think of it if I can take it out of all 3 of those and reduce it, then it will work, which is the case. The m does not exist in all 3, so I cannot reduce that. So this is your final answer on this one. Always remember that you do need to reduce at the very end if you can.